Hey guys, this is Bharani from Edureka, and in today's training session, we'll understand why is Internet of Things the next big revolution. So let's have a look at the objectives of today's training. We'll start off by understanding what exactly is Internet of Things, and then we'll have a look at the evolution of Internet, following which we'll go through the IoT architecture, and further, look at the different development boards used for IoT. And finally, we'll implement the concept of Smart Chair using Raspberry Pi 3. So guys, are we clear with the objectives? Kindly give me a confirmation by writing down in the chat box. Okay, so Ravi says he's clear. So does Sam. Pallavi has a question. She asks, is Arduino an IoT development kit? Well, yes and no, Pallavi. Arduino is actually an open source hardware and software company which manufactures single board microcontrollers to build your own IoT devices. So I hope this answers your question, Pallavi. Alright, so Pallavi says yes. Alright guys, now I'll take you through Edureka's IoT certification course. In this course, you will learn how to develop IoT solutions using sensors and components integration. You will be implementing IoT in big data and understand the utilization and modeling of extracted data. The use cases and hands-on included in this course will help you understand how the IoT technology is going to change the future, and by the end of this training, you learn the roles and responsibilities of an IoT developer. Right then, let's get started with our session. Now, what do you understand by the term internet? So internet is basically a network that is formed by connecting computers globally. Internet provides data highways to share information over the network from one place to another in the entire world. Now, when you expand the capability of internet from connecting computers globally to connecting several small electronic devices, Internet of Things is formed. So basically, smart devices with smart creativity creates IoT. Now let's look at IBM's definition of IoT. According to IBM, Internet of Things is the concept of connecting any device to the internet and to other connected devices. Internet of Things is a giant network of connected things and people, all of which collect and share data about the way they are used and about the environment around them. So now that we've understood what exactly is Internet of Things, I'll go ahead and look at the evolution of Internet. So in the pre-internet era, most of the human-to-human communication was through fixed and mobile telephony. The problem with landlines was you had to book a call with the operator and they would connect you when possible. So sometimes it could take hours or even days. And then with the origin of internet, the world changed at once. It provided a mechanism for information sharing without regard for geographical location. You could be continents apart and still share vital information at just the click of a button. And after the invention of blogging, social media began to explode in popularity. Sites like MySpace and LinkedIn gained prominence in the early 2000s. YouTube came out in 2005, creating an entirely new way for people to communicate and share with each other across great distances. And by 2006, Facebook and Twitter both became available to users throughout the world. Today, there is a tremendous variety of social networking sites, and many of them can be linked to allow cross-posting. This creates an environment where users can reach the maximum number of people without sacrificing the intimacy of person-to-person communication. And this is all fine, but the computers, and therefore the internet, are almost wholly dependent on human beings for information. Nearly all of the data available on the internet today was first captured and created by human beings by typing, pressing a record button, taking a digital picture, or scanning a barcode. The problem is, people have limited time, attention, and accuracy, all of which means they're not very good at capturing data about things in the real world. And if we had computers that knew everything there was to know about things, using data they gathered without any help from us, we would be able to track and count everything and greatly reduce waste, loss, and cost. We would know when things needed replacing or repairing and whether they were fresh or past their best, and this gave birth to Internet of Things. By now, you might have understood that IoT is not just internet-connected consumer devices. In fact, IoT is the technology that builds systems capable of autonomously sensing and responding to stimuli from the real world without human intervention. You therefore need to develop a process flow for a definite framework over which an IoT solution is built. So a thing in the context of the Internet of Things is an entity or a physical device that has a unique identifier, an embedded system, and the ability to transfer data over a network. These things are equipped with sensors and actuators, thus giving the ability to emit, accept, and process signals. Sensors are those devices which convert information from the physical environment into a signal, and actuators are those devices which act on the signal from the sensors and convert it into output. These things further send the collected information to hardware components such as Arduino Uno and Raspberry Pi. The data from the sensors starts in analog form, which needs to be aggregated and converted into digital streams for further processing downstream. Data acquisition systems perform these data aggregation and conversion functions. These data acquisition systems often sit in close proximity to the sensors and actuators. For example, a pump might contain a half dozen sensors and actuators that feed data into a data aggregation device that also digitizes the data. And there would be an adjacent gateway device or a server which would then process the data and forward it to the next stages. Once IoT data has been digitized and aggregated, it's ready to cross into the realm of IT. However, the data may require further processing before it enters the data center. Edge IT processing systems may be located in remote offices or other edge locations, but generally, these sit in the facility or location where they reside closer to the sensors, such as in a wiring closet. For example, rather than passing on raw vibration data for the pumps, you can aggregate and convert the data, analyze it, and send only projections as to when each device will fail or need service. Data that needs more in-depth processing and where feedback doesn't have to be immediate gets forwarded to the physical data center or cloud-based systems, where more powerful IT systems can analyze, manage, and securely store the data. You can execute a more in-depth analysis as well as combine your sensor data with data from other sources for deeper insights. Stage 4 processing may take place on-premise, in the cloud, or in a hybrid cloud system, but the type of processing executed in this stage remains the same regardless of the platform. So that was the IoT solutions architecture. Now we'll go ahead and look at the different IoT development boards. So we'll start off with Arduino. So Arduino is an open source platform used for building electronic projects. It consists of both a physical programmable circuit board and a piece of software or IDE. Then we have Raspberry Pi. Raspberry Pi is a credit card sized computer originally designed for education and inspired by the 1981 BBC Micro. Pi is a single board computer which is based on a Broadcom system of chip with an ARM processor of around 700 MHz, a GPU, and 256 to 512 MB RAM. The cost of a Pi is around $35 for a B model and is available through many online and physical stores. We also have Intel Galileo. Intel Galileo is the first in a line of Arduino certified development boards based on Intel x86 architecture and is designed for the maker and education communities. It is the first board based on Intel architecture designed to be hardware and software pin compatible with shields designed for the Arduino Uno R3. So those were some of the development boards used for IoT. Now we'll go ahead and understand how to configure Raspberry Pi. So our first step would be to download the Raspbian operating system from raspberrypi.org. So let's go ahead and do that. So we would have to download this Raspbian operating system. I'll download the zip file. Now after downloading the Raspbian operating system, we are supposed to load it onto our SD card. And before we do that, we would have to format the SD card. So we'll go to this site sdcard.org to download the SD card formatter. Now this software is available for both Windows and Mac systems, and since I'm using a Windows system, I'll download it for Windows. I'll go ahead and accept the license agreement and the download starts. Now after formatting the SD card, we would require a disk imager so that we can flash the operating system onto our SD card. So we'll go to sourceforge.net and download the Win32 disk imager. Again, I'll click on download and the download would start. Now, we would require a graphical desktop sharing system so that we can connect with the Raspberry Pi using a graphical user interface. So Real VNC is one such software which helps us to work with Raspberry Pi with a GUI. So I'll click on download VNC viewer and the download would start. And after performing all of these above steps, we can finally insert the SD card into the Raspberry Pi and connect the power cable to the Pi. And as soon as we connect the power cable to the Pi, it would start searching for open Wi-Fi networks. So what we'll do is, we'll turn on the hotspot in our system and the Raspberry Pi will connect to our computer's Wi-Fi. And once it gets connected to our computer's Wi-Fi, you can see the dynamic IP address of the Raspberry Pi. Now, we'll take this dynamic IP address and put it down in the dialog box of the VNC viewer. Now, when we do this, this gives us the graphical user interface to work with the Raspberry Pi. So let's go ahead and do that. So I'll go to settings and I see that the Raspberry Pi is already connected to my Wi-Fi network. And this is the dynamic IP address of the Raspberry Pi. So I'll take this IP address and put it down in the dialog box of VNC viewer. Now this gives me the GUI to work with Raspberry. Now we'll go ahead and understand the concept of Smart Chair. When it comes to Smart Chair, you can do much more than just sit on it. Let's have a look at the applications of Smart Chair. So with Smart Chair, you can save money on electricity and air conditioning costs. There would be a program running on the cloud which would keep checking if all the seats in the office floor are vacant for a specified amount of time, and the sensors in the chair would interact with the sensors in the lights and air conditioning systems and turn them off. Another application of the Smart Chair would be to find the vacant seat in an auditorium. Locating a particular seat in an appreciably large auditorium can be a daunting task, particularly when the hall is only partially full and people are standing. Knowledge of vacant seats will be of immense help to audiences who do not have designated seats. Knowledge of seat occupancy will also provide event organizers with data about seat occupation and attendance patterns over time. And on a funnier note, you can also put the IoT device under your boss's chair so that you get to know if your boss is in the cabin or not, and when he's not around, you can happily take a nap. So let's go ahead and build our own IoT based Smart Chair. I'll be working with the Raspberry Pi Sense Hat to build a Smart Chair. The Sense Hat features an 8x8 RGB LED matrix, a mini joystick, and sensors such as gyroscope, accelerometer, magnetometer, temperature sensor, humidity sensor, and barometric pressure. And this is the Python code which would help us to find out if the chair is empty or not. Let's go to VNC viewer and understand this code properly. So this is the code motion.py. Let's understand this. So what we are doing is we are importing the SenseHat package, and we would need the SenseHat package so that we can work with the SenseHat on top of the Raspberry Pi. We're also importing the time package so that we can put the Raspberry Pi to sleep. After importing these two packages, we are writing the entire code inside this class, which we have named to be sensor detection. And inside this class, we are reading the values from the SenseHat and storing those values in the sense variable. Now, what we'll do is we'll keep on reading the values from the accelerometer and store it into the acceleration object. Now, from this object, we'll take the values of x-axis, y-axis, and z-axis and store it into x, y, and z variables respectively. Now, these three variables would represent the values of x, y, and z axis. And after that, we'll round the value of x to its 0th decimal place. Similarly, we'll round the value of y to its 0th decimal place, and we'll round the value of z to its first decimal place. And after that, we'll print the values of x, y, and z. After printing the values of x, y, and z, we'll put the Raspberry Pi to sleep for 2 seconds. So what we're doing is, we'll print the values of x, y, and z, and then the Raspberry Pi will sleep. And after sleeping, if the value of z is greater than or equal to 0, we'll get a message saying that the chair is empty. Or on the other hand, if the value of z is less than 0, then we'll get a message saying that the chair is not empty. That is, If the chair is empty, then that would mean that the z-axis is positive. But what happens when someone comes and sits on the chair is the chair tilts back, and because of the inclination, the z-axis has negative value now, and thus we get the message chair is not empty. So let's go ahead and run this command in our terminal. We can run the code with this command. So we'll say python motion.py, and the code will start working. So what we see over here is these are the values of x, y, and z. And after printing the values of x, y, and z, we get a message saying that the chair is empty. Now, if I'd want to run the same code on my phone, I would require an SSH client. So one such SSH client available for both Android and iOS phones is the Terminus app. So I'll go ahead and download the Terminus app for my Android phone. After downloading this, I'll go ahead and execute this code on the phone. So now, as you can see, I've run the motion.py code on my phone. So I get the x, y, and z axis values. So along with those axis values, I also get a message which tells me that the chair is empty. So now my friend is going to come and sit on the chair. So as my friend sits on the chair, we see that there is a change in the value of the z-axis, and also the message has changed. Now we see that the chair is not empty. So thus we have implemented the concept of smart chair with the help of the Terminus app on our phones. So this brings us to the end of this video. So we started off by understanding what exactly is IoT, and then we looked at the evolution of internet. Following which, we looked at the IoT architecture, and then we looked at the different IoT development boards. After which, we configured our Raspberry Pi and understood the motion.py code with which we found out if the chair is empty or not. So hoping that you liked the video. Thank you.